Hello, let's learn about how to use the right-hand rule to figure out the force on a current carrying conductor. Here, I have a magnetic field set up by two separate magnets. At the bottom is the north pole of one magnet. At the top is the south pole of the other magnet. Since the field lines are moving out of the north pole, you can see all the magnetic field lines are pointing up in this case. We are going to consider current flowing in different directions. Current has a direction, but it itself is a scalar quantity, so there is no vector symbol for current. The current could be flowing to the right, out of the screen, to the left, or into the screen. In each case, we need to find the direction of the force on the current carrying conductor. First of all, let's review what the right-hand rule is. To use the right-hand rule, we need to hold our right hand out, keeping the hand flat. All the fingers are straight out, ideally putting them close together. The fingers are pointing in the direction of the magnetic field. The thumb is being held 90 degrees from the fingers, and the thumb is pointing to the direction of the conventional current or the velocity of positive charge if we are considering charged particles. The palm is pointing in the direction of the force. Let's give this question a try. First of all, we align the fingers in the direction of the magnetic field, which is pointing up in this case. And then we will twist the wrist until the thumb is pointing in the direction of the current, which is to the right. As you can see, the force is now pointing toward us, or the palm is facing toward us, so we know the force is moving out of the screen. This is where the conductor is moving. Next, let's see what happens when the current is pointing out of the screen. Again, we will align the magnetic field first. And then we twist our hand until the current is pointing out of the screen, which is the thumb here. The thumb is pointing out of screen. As you can see, the palm is pointing to the left, so the force is pointing to the left. Next, let's find out the direction of the force when the current is pointing to the left. We will align the fingers with the magnetic field, and then the thumb with the direction of the current. As you can see, the palm is facing away from us. It is facing into the screen. So the conductor will move this way. Lastly, we need to figure out the force when the current is pointing into the screen. Again, we'll align the magnetic force first. And now the current is pointing into the screen. If you feel that is not comfortable, you may twist your hand in the other way, in the other direction. You will get the same result. Here, you can see the palm is pointing to the right. So the current carrying conductor moves this way.